Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate
We've been solving exponential equations using some various techniques. Let's review two of them because I want to show you how you can apply them in special cases with logarithmic equations. Let's look at the first one here. This is 2 to the power of x equals 64. So if I can make the bases match here, then the exponents will be the same. So 64 is 2 to the power of 6. Now you may know that from your list of powers. If not, just do a quick prime factorization tree and you get that. So we're going to rewrite 64 in terms of 2 to the power of 6. Now notice the bases are the same, and when the bases are the same, then the powers are equal. And there's our answer. Now let's apply a similar logic to this one. So this is y to the power of 3 equals 125. Now in this case, the base is unknown. So what I want to have happen is I want to try to make the exponents equal because then the bases are equal. So I'm going to take 125 and break it down into a quantity that is cubed, or a power of 3. So 125 is really 5 to the power of 3. So I'm going to rewrite 125 as 5 to the power of 3. Here, you can see that the exponents, or the powers, are the same. Therefore, the bases must be the same. This idea with our exponentials of making the bases the same or the powers the same in order to find the other can also be applied to logs. So let's look at these equations here. So again, we're going to solve them. So on the left, we have log base 3 of w equals log base 3 of 20. Now notice the bases of the logs are equal. So the same principle applies. Since the bases of the logs are equal, then the arguments themselves must also be equal. On the right here, we have log base m of 9 equals log base 4 of 9. In this case, the arguments are equal. So, since the arguments are equal, then the bases are equal. In this example here, you can see that this is a little bit different than what we just got done doing. There's a -1 here. Also, 4 and 50, they don't really have a common factor that we can rewrite in terms of powers that would make them equal, or bases that are the same. So we can't really use what we just did. So I want to introduce you to something new, something called the change of base formula. Take a moment and write this down. Be very careful how you place everything. Let's go over what this formula tells us. This says if you have log base b of c, some quantity, you can actually rewrite it as a quotient. Log base a of c, so that's the argument there, divided by log base a of b, which is the base. Something to note, when you do this, the base of both of these logs must be the same. And you can actually type this in your calculator and then get an answer. So I want to show you how this change of base formula can be applied when solving problems such as these. So our first step here is we're going to convert this into log form. Now what I want to show you here is this is log base 4 of 50. So we're going to follow this format here. So 50 is c and b is 4. Now there's no log base 4 button on your calculator. There's only common log or natural log. So change of base formula allows you to calculate this logarithm using a different function like common log or natural log. Remember, this is just some number. So we're going to use our calculator in a moment here to figure this out. But first we got to set it up. Following the change of base formula, we're going to rewrite this in terms of a common log. So we're going to say log of 50 divided by log of 4. So the base is both 10. So log of 50 divided by log of 4. That's what this says. It says log of c divided by log of b. Now, what log you choose to do it in, you can use log, common log, or you can use natural log. It doesn't matter. So that equals x minus 1. Now let's solve for x. What are we going to do? We're going to add 1 to the other side. Now let's use our calculator.